You. Can you hear me? Are my thoughts still private? Okay. So yes, this is a continuous integration presentation, which means it was delivered just in time. So I'm from Atlanta, and since 2006, I've been involved with OpenSARE/Kamailio. And at this point, the primary business of Every Systems, that very one, is a class 4 switching and routing product called CSRP. And I'm going to talk not about CSRP from a promotional perspective so much as how certain problems that it solves for its customers are solved in Kamailio in a very specific level of implementational detail. But one must start with the question of what is it? And so CSRP is a class 4 switch platform that has a couple of different use cases, and it's built entirely on top of Kamailio. The only platform I know of that takes a very purist approach and really is foundationally built solely on Kamailio. It's a class 4 switch of sorts in that one connects PBXs or hosted PBX application delivery silos, ATAs, application servers, and other customer gateways to the PSTN this way. And that can mean either SIP links to internal TDM gateways, or it can mean just SIP wholesale or retail origination and termination providers. So in other words, it is the PSTN connection box that one would typically put between one SIP infrastructure and the surrounding world, but a rather lightweight one. But I think classically we internally refer to it as a trunking platform. And a trunking platform is a platform that delivers SIP trunking, which means it performs, among other things, some of these functions: routing to the PSTN via LCR and by other means, distribution of incoming calls to customer endpoints, capturing cost information for all, rating those calls in real time, solving certain technical problems involved in delivering SIP trunking and SIP connectivity, like far-end NAT traversal most classically, providing a certain amount of product-oriented business logic, like the exact way that you would like failover routing to happen. Some options like voicemail to email and call forwarding as well. All right, then.
Okay. No, just
Support for certain financial characteristics of that process, prepaid credit, and various types of fraud control, and a little bit of, you might say, very lightweight kind of SBC functionality, although I very much am opposed to that terminology. But I did say it's a PSTN connection box, even though it's not really a box. It has never been an appliance, and I highly doubt it in 2016 it ever would be. It's a pure software product, and it's installed on customer-operated servers. Nor is it a hosted switch platform, nor do we have a hosted offering, but I think it would be a good core technology to develop one, because it has a multi-tenant architecture. Now, with the cloud apocalypse fully in play, it hasn't been entirely lost upon me that this whole notion of a hosted switch platform is a bit arbitrary at this point, given the nature of the product. To me, if someone came along and said, "Can you host CSRP for me today?" I would say, "So you want to put the Rackspace server on my credit card and not yours?" As I see it, most of our customers run this in a virtualized environment of some description or another, with the exception of course, media handling elements. But box is a comforting marketing vocabulary for telco types, so we'll probably continue to use it because it's kind of geometrically evocative. It's a spot on a UML diagram. So it's a class 4 platform, and like I said, it's designed to connect PBXs, ATAs, application servers, SBCs, soft switches with an IP appendage and the like, but it's not really designed to service handsets, soft phones, end user endpoints of any sort directly. That doesn't mean you couldn't connect a handset to CSRP if you so desired, but it's really designed to be a switch-to-switch network element. Disruptive innovators clearly use it. And it's worth saying that it's hard to generalize about CSRP customers because they do fall into a number of different segments. I think our classic mainstay customer, if I had to pick one, would probably be the wholesale and retail SIP provider market. So something like a Vitality or a Flow Route. No, they're not our customers. That'd be nice. Or wholesale SIP-a-ridge and term vendors. So, we have a certain short duration constituency, which I spoke about, lampooned to some degree in depth last year, and you're welcome to find my presentation from last year on YouTube if you want to see more about that. And CSRP, despite its fairly ample business layer feature set, has always been fairly committed to meeting the technical needs of short duration traffic runners in terms of throughput. So one of its main selling points is that you can run 1,000 to 2,000 call setups per second on a commodity pizza box without much fanfare or ceremony, despite having a fairly heavyweight call processing loop. Some CLECs also use it for primarily for kind of niche internal projects. And also, we have some customers who really are just internal consumers of what CSRP provides. So CSRP enables the classic PSTN minutes business model most canonically, but we have a couple customers who consume it for purely internal purposes. And there's a particular category of increasingly sophisticated call center that is looking for its own LCR options and to take more effective control of its own PSTN interconnection instead of just buying from the aggregators and who typically sell to the wholesale call center space. And broadly, it's based on a SIP proxy, Kamailio at the center with a Postgres database in the back, with an outboard RTP proxy in the form of RTP engine nowadays. And then SEMS is used for certain niche applications within it. SEMS is not used in a critical path application. That is to say, we don't transit our calls through SEMS by default or shunt them through a B2B UA by default. But that is a thing that can happen in certain call setup scenarios, and SEMS is used to deliver that. We use a Redis caching layer, and we have a Node REST backend that the web UI drives and also provides another integration path. Our historical customer is fairly technically minded and is of this, it's a self-selecting group, right? But historically, they're looking for integration paths into some larger OSS, BSS systems. So we've always been kind of weak on the UI side, to be candid with you. We have one, but at this moment, it's actually undergoing a major rewrite with the aim of finally, improving usability to a fairly high standard. In the past, our typical customer is like, well, we have a zoo of 6 or 7 network elements, and we're not really interested in teaching our support people to log into yet another one. What we want is connectors, APIs, database access, documentation, schemas, specs. Give those to us, and we're just going to wire it all up to our OSS, BSS system so the business guy can press a button and things get provisioned. That's the aspiration anyway. We tended to focus on that kind of customer historically. The business layer in CSRP resides in Postgres stored functions, and the historical reason for this is that the Kamailio scripting language, although it is increasingly sophisticated, it's ultimately not a general purpose programmatic runtime. So it doesn't offer the transactionality or the data structure primitives or other things you'd need to implement a fairly complex business layer beyond just the sort of call processing thing that goes on in the Kamailio DSL. I think with the coming Lua apocalypse in 5.0, we may need to revisit that point of view, although we should be very mindful of the performance implications, possibly. So Kamailio calls out to Postgres for call processing for all phases of authentication, accounting, and so on and so forth. It uses a few built-in Kamailio modules, but very, very few. So what we've got is a very custom design with very few built-in Kamailio modules that are used, basically just registrar and user lock at this point. Everything else is completely custom, and the basis for that is that a lot of the Kamailio modules, the historical, more canonical ones, are really just syntactic sugar for database interactions that I think hark back to a time when generic database connectors were not weren't easy to come by. So we need a lot of esoteric business logic. So rather than trying to shoehorn it into like the carrier route module and the LCR module, everything is just bespoke for this application. So it looks kind of like that. So SIP invite comes from the customer network edge, and Kamailio just interacts with Postgres repeatedly in its call processing loop. But most of the logic lives in stored procedures, which has two advantages. One is that it limits the amount of SQL data marshaling that you have to do back and forth between the client, caller, and the database. So you don't have to pull out the output of one query, feed it as input to another query, rinse, repeat. Most of the bulk processing can happen at the database, and of course you get the benefit of transactionality and atomicity there as well. And I suppose the second benefit is that it doesn't really require a lot of moving parts. It's relatively conservative, and there is a Redis caching layer for the low-hanging fruit. So what most customers want, and this is really the substance of my presentation, are a couple of different things. They want things like server-side NAT traversal, fairly ubiquitous requirement. They will, however, avoid paying for hairpinning RTP if they can, because, well, I have a customer that ran 140 megabits of RTP at one point, and as you can imagine, with a single instance of RTP engine, kudos, and ran into some rather expensive cost factors in so doing. So for NAT traversal, we use NAT helper folk traditions, although the more new add contact alias and RURI alias methodology, and the RTP engine for media relay, where and if required. We have a lot of customers that are NATed, but they're, operators whose customers are NATed, but their traffic still makes it to the carrier for one reason or another, be that either ICE or port forwarding or some other means of getting around that problem. Nearly universally in the wholesale SIP world in North America at this point, you need LNP queries. So we make them via SIP redirect to various derivatives of the Newstar supply chain. And since almost all wholesale SIP termination providers bill on the terminating carrier at this point, you really need to know where your call actually went. And a couple years ago, it was sort of like, well, carriers are moving to this model. No, the movement has been completed. LRN dips are a must if you're doing wholesale SIP termination in the US at this point, or you're simply not going to get accurate bills or do accurate reconciliation. So we use the RFC 4694 notation to parse out the terminating LRN. And that same concept is used in other number portability requirements around the world, which is why it's an IETF RFC. So we forward the invite to the service provider's redirect server, catch the 302, move temporarily and whatnot, parse out the LRN from the contact header, store it, use it, do our LCR lookups based on it, and so on. So practically that looks like that. But I think a line-by-line code review would be not so entertaining. Another thing that our customers are curious about is measuring call setup latency, and that includes all phases of the necessary state transition. So not just how long did this Kamailio route run or how long did this instruction set run, but really, I got the invite, I sent it to a redirect server, I got an LRN back, I did some other stuff, I may have pinged another piece of network intelligence, then finally it's going out to my first vendor. How long did all of that take? So we actually use the time val pseudo variables for calculating that in this manner. So that computes the milliseconds between proc start and cur time. We have a need to write CDRs more or less in real time, even when the resulting I/O load is fairly punishing, and to rate them in real time. So we don't do post rating, we do real time rating. The goal is to take the computational punishment up front in small doses instead of some sort of big analytical job later. And the first phase of that is done in Kamailio. So CDRs and CSRP are written in an entirely asynchronous manner, meaning that they're not in series to the call processing loop. So when a CDR event occurs, we push that off onto an MQ and consume it with 4 R-timer threads by default. And we basically push events look like this. We do a kind of approximately round-robin distribution of CDR events among these 4 R-timer threads by hashing it into a hash space of 4, which is to say hashing the call ID. And we send key value pairs onto the MQ and then base 64 encoded and then decode them. and push them into a stored procedure, which then does the actual unmarshalling there. And I'll talk about why that approach is kind of obsolete in a minute. But another thing our customers very much care about is terminating carrier PDD. And unfortunately, the Kamailio TM module has no timer that is compatible with their business level understanding of what PDD means. So they're typically, with their grievances, we got a 180 ringing or a 183, and then nothing happens for a while. And they need some failover mechanism for that. So the way we handle that is we initially set an invite final response timeout that's 3 seconds, 4 seconds, whatever you've configured the trunk group to. And then when we get a reply that resets the PDD timers, we reset the final reply timer on the invite transaction in the on-reply route. Enforcing call setup rate in a logically independent way for both customers and vendors is also a common requirement, since a lot of our installations are very high volume. We use pipe limit for that, because as of 4.0 or 4.1, it allows the creation of arbitrary numbers of pipes. They don't have to be statically defined. They can be bound at runtime, and if they don't exist, they'll be created. So we use pipe limit for that to great effect in this very compact manner, something that used to be quite laborious. There are a lot of implementations for sampling CPS. Prior to this point, we had, well, I think we settled on an H-table-based one, but this is just much easier and more canonical. So if you're not familiar with this idiom, I think this will simplify your life if you have a need to rate limit requests. Some customers of ours like to take control of the uncertainty inherent in how SIP cause codes get translated in ISAP land. And so we do have support for playing early media announcements. We do that with SEMS. It can be done in a variety of ways. Pretty much any media server like Asterisk or FreeSwitch lend themselves to that readily. We use SEMS for it because it's just lighter weight and easier to embed and package for us. And the early announce application in SEMS does this very well. So what we'll do is we'll fork off a branch to SEMS, which will send back a 183 plus SDP, play out the announcement, and then we signal to it what we want the final reply to be. SEMS will respond with that as a final transaction disposition, and we'll kick that back to the caller. Modifying from and to is also fairly essential. And we don't like to do it. Proxies shouldn't do it, but Kamailio has the technical capacity to do it, and there's a variety of reasons why one must inevitably in real-world operations do it, and we leverage UAC for that. It has a clever mechanism for statefully rewriting to and from and storing the original value in a record route parameter writer, which gets statefully decoded so that the calling endpoint is none the wiser as to the fact that the proxy manipulated something in transit that it shouldn't, which is not altogether different from the approach taken by the topology hiding module and probably a couple other constructs. We have to load a custom route set from the database. We have business rules around how we route advance. And I think my intended takeaway here for you is that actually SQL ops and data structure primitives like XAVPs give you fine-grained control over this. So periodically we see discussions on the mailing list that reflect this certain kind of narrowly conceived view like, well, dispatcher doesn't do this for me. Well, you don't need dispatcher, you don't. Dispatcher is a compact and efficient way to implement something straightforward and well understood like, say, round-robin distribution. But you don't actually need it, you can write it yourself. All you have to do is put some state in the transactional or dialogue persistence layer, depending on what you're trying to do. And you can write all this logic yourself, and the tools are there. And so we take that approach to Kamailio. We use almost none of the built-in modules, except for the SIP fundamentals in the core. But really, if you want to get, say, something like the dispatcher module or carrier route or LCR to do what you want, and it doesn't do what you want schematically, you have a choice of whether to try to shoehorn your data set into it or to just do it in a bespoke way, and that's what we've done here. So iterating through this route set that we pull out of the database with our route set LCR procedure, xquery automatically buffers it into an XAVP, and then you can iterate over it as a normal AVP array. So we do that in a variety of situations, and then our failure route advances the current array index, and along the way does whatever you like. And that's the point, is you're not really constrained to doing what the stock Kamailio formula demands that you do. That's the whole power of these DSL callbacks. It's not uncommon to use CSRP to bridge disparate network topologies where the endpoints can't reach each other. And that can be due to direct interconnects with other entities across private IP or MPLS, or multiple source addresses required for multiple SIP products to the same vendor, or just kind of an SBC role for CSRP. And CSRP gets begrudgingly conscripted into a kind of SBC light role in that situation. But fortunately, Kamailio is almost magical in its handling of that. It's very easy. We use the force send socket to determine which outbound interface to send a request out of, and should that if Kamailio is listening on multiple addresses, it'll automatically add the right record routes, add two of them, one for ingress, one for egress, and all the subsequent signaling will automatically reflect the correct order of ingress and egress and so on. I also fairly recently learned that we, in fact, for running Kamailio in NATed environments like AWS, there's an advertised parameter to the listen address, and it too takes care of this problem in a very seamless way. So I think what we'd like to do in the very near future, we're pretty aggressive about taking advantage of new Kamailio capabilities. And what I think we'd like to do first and foremost is take advantage of some of Postgres' native JSON support in combination with the Jansen module to just avoid a lot of unnecessary string parsing and data marshaling. Because right now we do a lot of regex in our stored procedures, because when you want to parse strings fast, you should do it in a database stored procedure. I think there's some performance benefits as well as some kind of programmatic, idiomatic benefits to making this more generic, not to mention more humane. Definitely interested in DMQ as a technology for distribution of various kind of state that can lead to higher availability setups, and more flexible. I would say maybe we should take broader advantage of asynchronous capabilities. So that's about all. I wanted to make one more remark, which is, being in the good old call termination business indirectly by way of our customers is not a particularly photogenic thing for a conference like this. We're certainly not disrupting anything or part of the real-time communications revolution, as it were. However, at least by the numbers, in North America, I would say this is still by far the most canonical kind of use case for Kamailio, quantitatively, statistically. I was here in 2013 and said, oh, the PSTN is not going away in North America anytime soon, if for no other reason than its balkanization, I guess you could say. And I'm standing here 3-4 years later, and that seems to be true for the moment. And in being in this space, we're fairly allergic to kind of grandiose ideas and largesse. What I think what we like to do instead is to substitute open source technology into a pipeline of incremental process improvement. There are discontinuities, critical moments, watersheds, tipping points, and so on in the adoption of things like end-to-end IP communication. But where I see the PSTN in North America changing is rather in the fact that IP interconnects are subtly and insidiously worming their way into use, that there are increasingly large amount of IP network intelligence products, things like that. I think the change is happening quite incrementally, and I think CSRP is our best vehicle for investment in that viewpoint. Thank you.
Thank you. Question here. Tori, almost to the limit, but we don't have many.
Just a question. I saw you were using NetHelper. Have you ever considered migrating from NetHelper to the SIP outbound module?
Well, to Ule's point, there isn't much developer demand, not much customer demand for it as well. We certainly considered it, but to be honest, we're mostly trafficking in UDP, and so are most of our customers, including their end user endpoints. I think that use case will become more common in the foreseeable future. For now, we haven't contemplated it, no.
Okay. Other questions from? Then my question would be, do you think like those small operators will migrate from like a dedicated solution to this kind of cloud-based? Because now it's a lot of like hosted PBX. Mm-hmm. Do you think that's gonna go also in these lower layers, class 4 and so on?
So in other words, do you see the approach to class 4 becoming more cloudified? Yeah, to some extent that's already happening. I think you see it mostly in the call center world right now, which is dominated by hosted switch platforms and has been for a while. I think most of the traditional business voice focused operators that we deal with still are more comfortable managing some infrastructure themselves. But in practice, it's all on leased dedicateds or large VMs. So in terms of who concretely owns the infrastructure, I think there's widespread consensus that I don't want to own anything and operate anything. But this is a product that runs on a customer-defined environment on their servers. And I don't know that I really discern a strong wind of change in that regard. I think it's a complex enough, high-touch enough product that it's very well suited to that kind of deployment methodology. It doesn't lend itself to, Dockerization and infinite horizontal scaling and automatic discovery and all this.
Okay. Questions? More? Okay, so thank you, Alex, again, for all support all these years.